I'm going to do page 3 of this energy notes worksheet. We've already done 1 and 2 in a previous video. We've got a piano with the following mass, slides down a 3.6 meter incline, 28-degree angle. You've got some friction. The man prevents the piano from accelerating. So what does that mean? That A equals 0, Newton would then say F net has to be equal to 0. So in order to prevent the piano from accelerating down, he must apply, obviously, a force in this direction to counter the force of the mg sine theta going down the ramp. Now, here's the other thing now. So you've got mg sine theta going down, but which way does friction act? Friction's going to oppose the motion, so friction will act this way. Little f is friction. So the two things preventing the car from accelerating is the applied force, the man's force. Now, it didn't say it was applied this way, but if it's not, if they don't mention an angle, we have to assume he applied it this way whenever they leave out the angle. So the man's applied force and the friction force will act up the ramp, and mg sine theta will act down the ramp. So if the sum of the forces equals 0, let's go back to what we always did. The up forces, up the ramp, equal the down forces. So the up force is the F applied, and the down force is mg sine. Whoops, that's a mistake. There are two up forces. There's the applied force plus the friction equals the only down force, which is mg sine theta. So what is the force exerted by the man? His applied force equals mg sine theta minus the friction. So friction is, well, first of all, mg sine theta minus, now what's friction on the ramp? Mg cosine theta, the normal force, times mu. So F applied, whoops. So let's get out now. Let me see. I don't even know if the solution uses 9.8, but I think I'll use, I got a feeling it does. Yeah. Use 9.8. So mg sine theta is 1518.27. Mg cosine theta mu, the normal, times the coefficient, the friction. All that equals 1142.181. That's newtons. And when you do the subtraction, you get 376 newtons, which turns out to be 380 newtons. Which direction? Up ramp. You might even want to call it negative 380 if you just decided to give it if you wanted to call up negative and down positive, which we'll do later on. So 380 newtons is the force. It's F. What is the work done by the man? Now, what kind of work does the man do? Well, let's see. The displacement is down the ramp, and he's applying a force up the ramp. He's doing negative work. Now, work is F cosine theta times d. Now, what is the angle? What is that theta? It's the angle between the force, the direction of the force, and the direction of the displacement, which is down the ramp. Force is up the ramp. So that angle is 180 degrees. So press in cosine. So 180 cosine, what's that? That is, no surprise, negative 1. So this becomes, so this equation becomes W equals F cosine 180D. So the force is 380 newtons. We found it. This is the work done by the man. That was his force. Cosine 180 is negative 1. The D is given as 3.6 meters. 3.6 meters. We'll just multiply it out. Times 3.6 times 380. Work is, let's see. it turns out to be negative with two significant digits. It turns out to be negative 1.4, rounds up to 1.4 times 10 to the 3 joules. And remember, joules is a unit of energy, or you can answer newtons times meters, because you multiplied a newton times a meter. So a newton times a meter is a joule, and there you go. Let's go over it again. What's the force exerted by what is the work done by the man? Well, it's the force exerted by the man times cosine theta, and the angle between the direction of the force and the direction of displacement is 180 degrees. They're actually opposite. The distance was given as 3.6 meters, right? 3.6 meters, and there's the work. F cosine theta d. What is the work done by friction? Okay, work done by friction. Which way does the friction work? Let's see. The object goes down, the displacement is down, the friction's up, and actually, once again, F cosine theta d, the theta is 180, so it's F times cosine of 180. The direction of the force and the displacement are opposite, so it turns out to be negative FD. It's a negative. That friction does negative work. It acts in the opposite direction of the displacement. The work is, so the cosine of 180 is negative 1. So let's do work equals the force of friction, which is, what is friction? Well, you remember this, mu k, mu times mg cosine theta. The mg cosine theta, that's the normal force. That's the friction force. Mu times mg cosine theta, mu times normal, times d, and that's negative because that's what the cosine of 180 is. So equals negative. Friction is 0.4, I think it was. 0.40 rather, 0.40. Mu is 0.40. Mg is 330 kg. And like I said, I believe this key uses 9.8. You don't have to. You'll get a slightly different answer if you use 10. No big deal. You can use both. Mu mg cosine of 28 degrees. The ramp angle is 28, I think. 28 degrees. Now, remember when we use cosine, it's the angle between the force and the displacement. That was 180. Cosine times the d. This is getting pretty hairy. The d is given as 3.6, also two significant digits. And so now you just put it in a calculator. Negative 0.4 times 330 times 9.8 times cosine 28 times 3.6. When I do it with my calculator, I know what you do. I always do the trig first, then I work backwards. So I'll do the cosine 28 times 33.6 times 9.8 times 330 times 0.4, and that the work done by friction is a negative 4.1 times 10. Remember, I'm using 9.8 to the third joules, or newtons times meter. It's negative work. It's work that's acting in the opposite direction of the displacement. The friction doesn't works up the ramp. Now, this is getting pretty hairy. What's the work done by the force of gravity? Well, what is the work done? Well, it's again, which is W is F cosine theta d. Now the force of gravity acts down the ramp. That's mg cosine theta, sine theta rather. Works down the ramp, so that theta is 0. The displacement's down the ramp, and the gravity acts down the ramp, so that's 0. So work is cosine of 0, I think you know, is 1. So it's just W equals FD. This is positive work. Gravity does mg sine theta, is the work of gravity, works down the ramp. And times d, which we're given now, just multiply it all out. And if I use 9.8, that work done by gravity is 5.5 times 10 to the third joules. If you put all the numbers in, what is the net work done by the piano? Well, that means all the forces. F naught times D. It's actually a lot easier than you think, because when we were told that the man applied a force so it prevented the car from accelerating, well, okay, let's go back to Newton. There is no acceleration, so what Newton would say is the F net is 0, so the work would be 0. And if you add up all the different works that I got, all these things in boxes, all the positive and negative works, they should add up to 0. They may not because of rounding, but so what you get is this. You've got the work we got, what, negative 1400 was the first? Yeah, negative 1400 was our first one, negative 1400 joules. We calculated another work of negative 4100 joules. And then you got that big positive work of 5,500 joules. And it all adds up to 0 joules. And there you go. Whoa. So that's a good example of just how to do positive and negative works, how we have to include that cosine theta when it's the force is acting in direction of the displacement. Theta is 0 when the force is acting in opposition to the displacement, in the opposite direction of displacement. Then it's cosine 180, that's negative 1. So you might want to rewind that and look at that again. I think it might be a good place to stop.